Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to wrap up our rational expression and equation chapter, guys. And we're going to wrap it up by learning how to solve rational inequalities. The good news, rational inequalities is actually, in my opinion, way easier than rational equations, okay? The not so good news, it's not bad news, but there are some extra steps that we have to follow in rational inequalities. But luckily, all of the skills that we've learned in the past will be used here. So we're going to be adding some extra steps, but they're not extra steps that are unknown to you. They're not extra steps that you've never seen before. These are all things that we have learned in the past. And a rational inequality, similar to a rational equation, is an inequality that contains rational expressions. Here's some examples of rational inequalities. I got 1 over x is less than 1. That's a rational inequality because it's a rational expression and it has an inequality sign. So that's a rational inequality. I got 3 over x minus 5 is less than 4x over 2x minus 1 plus 1 over x. That's a rational inequality. Right here is a rational inequality. This right here is a rational inequality. So if you have a rational expression set with an inequality sign, that is a rational inequality, and that's how you recognize them. Now, how do you solve them? Very simple. Okay. Number 1, set the given inequality to 0. In this particular case, it's already set to 0. If it was not set to 0, if you had something being added to it or multiplied to it or subtracted from it, okay, you're going to have to bring everything over on the right side or the left side so you have 0 on one side and you just have an inequality on the other side. So I don't care how complicated they put it at first, this is the end result for you. You want to set the given inequality to 0, okay, so that a single quotient is a fraction, division, so a single quotient or simplified expression, simplified radical expression, rational expression rather, is formed on one side. So I don't care how complicated they give it to you, you want to set that inequality to 0 so that you have one rational expression on one side of the inequality and a 0 on the other side of the inequality. So in this particular case, I have nothing to worry about because I've already done step 1. So this is done. Step 2, okay. It says solve for and find the zeros and, there should be an and here, and undefined values of x. Wait a second, undefined values of x. We've seen that before, haven't we? How do we find undefined values of x? All right, sir. Set the denominator to not equal 0. Thank you very much. Because I cannot have 0 in the denominator. So I must find the value of x that creates a 0 in the denominator because that's undefined, and that's the undefined value. Okay? Now, you find the zeros, guys, by setting the numerator of the rational expression equal to 0. You find the undefined values by setting the denominator to not equal 0. Now let's think about this. You're setting the numerator equal to 0. Why? If I have 0 over x minus 4, what's 0 divided by x minus 4? 0. So that's why you're finding the zeros here. But if I make the denominator 0, then I have x plus 3 over 0. What does that make it? Undefined, right? So that's where you find your undefined values. So to find your zeros, you set the numerator equal to 0. Forget about the inequality sign for right now. You set the numerator equal to 0. You set the denominator not equal to 0. So for step 2, my zeros, in this case I only have 1, is what? You go x plus 3, set it equal to 0. So x equals negative 3. That's my 0. Now, you want the undefined values. So you set the denominator, which is x minus 4, to not equal 0. So x cannot equal 4. So x equals 4 is my undefined value. So x equals negative 3, that's my 0. If x equals positive 4, that's my undefined value. X cannot equal 4. So that's my undefined value. Is everyone with me so far? Please ask. I'm here for you. Okay. Now, here's the different part. This is easy. I'm not trying to stress you out. It's easy, but it's going to look a little funky at first. Just bear with me. I promise you, this is easy. So just bear with me and have an open mind, please. Step 3. Plot the solutions, which are your zeros. Solutions are zeros. Okay? Plot your solutions or zeros, and the excluded values. Excluded values are your undefined values. Right? So you're going to plot your zeros and undefined values on a real number line and test each interval in order to find the sign of your original rational expression. Please remember that a negative divided by a negative is a positive. A negative divided by a positive is a negative. A positive divided by a positive is a positive. And a positive divided by a negative is a negative. This is old school stuff, which hopefully you remember. Now, we have our number line. I'll make a little number line. Always put your 0. Okay? Because 0 is important. That way you have a reference point. What are the zeros here of this inequality? Negative 3. So go to negative 3. And what's my undefined value? Okay, so 1, 2, 3, and here's 4. Okay. Go ahead and draw exactly what I did there because I'm going to show you what these test intervals mean, how to find it. What does he mean? What does he mean by test the intervals? What is this crazy man talking about? Go ahead and write that down, please. Let me go ahead and just get this real quick. Is everyone with me, guys? Because I want to show you so you can really understand and see this. All right, guys. So you have a solution here at negative 3. You have an undefined value here at 4. Okay? So my intervals are the following. The solutions to this can be less than negative 3. So I'm going to call this my first interval. It could be between negative 3 and 4. So I'm going to call this my second interval. And it could be greater than 4. That's my third interval. Now, notice how I marked negative 3 with a solid dot and 4 with an open dot. Can x equal 4? No, that's why it's open. Can x equal negative 3 though? Yes, that's why it's closed. Remember, closed circle is greater than or equal to or less than or equal to. Open circle is greater than or less than. So I have 3 intervals here, right? Now, according to what I was given in my inequality, when I plug in values for this from these intervals into my inequality, what does this answer have to be? Greater than or equal to 0 or less than or equal to 0? Greater than. So now, let's test to see which one of these 3 intervals gives you a value plugged into this inequality that's greater than or equal to 0. Are you understanding what we're about to do? Okay? Yes, sir.
So, like, if it has to be equal, so then, well, no, actually,
It's going to be greater than or equal to 0.
That's not what I was going to say.
Okay? Okay. What's a value that is less than negative 3? I don't care which one. Or equal to negative. Okay? Negative 4. So let's try this out. Negative 4 plus 3 over negative 4 minus 4. I don't even have to calculate the value here, guys. Negative 4 plus 3, that's going to be a negative, right? A negative 1. And then down here you have another negative, right? Negative 8. So what's a negative divided by a negative? Positive. Any positive number, is that greater than 0? Yes. So since this gives you 1/8, 1/8 is greater than 0, this works. Now, what's a nice, pretty simple value that I can choose for x in interval 2? How about easier than that? 0. If I put 0, guys, am I not left with 3 over negative 4? Is that greater than or equal to 0? No. So this does not work. Now, I'm going to prove to you that 3 works, but just so you know, there's a pattern here always. If this first interval works, the third interval will work always, and the middle will never work. If the first interval doesn't work, but the middle interval does, the third interval will not work. But you'll see the pattern as you continue. So what's a value greater than 4? Because I cannot use 4. 5. Okay, 5 plus 3 is 8. 5 minus 4 is 1. Is 8 greater than or equal to 0? So it works. Go ahead and write that down now, and then I'm going to show you how to write your answer in. Remember interval notation, guys? With, no, not with exponents. No, that's not interval notation. That's scientific notation. Great, but at least you're thinking. Thank you, my brother. Interval notation, remember, is with brackets and parentheses and the infinity sign? Good. So again, nothing new here, really. Just a bunch of old stuff put together. So I know that my solutions can be less than negative 3 or greater than 4. So what is my solution here? My solution, I know that x can be less than or equal to negative 3, right? And or greater than 4, right? But that's old school notation. That's Mickey Mouse notation. Real notation is going to be interval notation. So I've got from negative infinity to negative 3 in, this should be in brackets because it's less than or equal to, in union with parentheses 4 to positive infinity. How did you get that? Just look at the graph. The graph, am I not going from negative infinity all the way to negative 3? Am I not going from 4 all the way to positive infinity? That's the easiest way to ensure that you have proper interval notation. Yes, sir? No, sir. When you have a parenthesis around the 4, that tells the reader that it's not equal to 4, but it's anything greater than 4. He had asked if shouldn't it be 5? No, because 4.1 is no longer 4, and that would be valid. Thank you for caring, and thank you for asking, sir. Does that make sense, gentlemen? Questions on this, gentlemen, before we start doing practice, because that's the lesson. Okay. Let's move on then. Let's do this. Step 1. What's my 0 or zeros? Okay, so my 0 is x can equal 7, right? What's my undefined value or values? X cannot equal negative 3. Let's do a number line. Put a 0. Here's a negative 3. Here's a 7. Open circle on the negative 3. Close circle on the 7. My intervals to the left of 3, negative 3, in between negative 3 and 7, and to the right of 7. Does everyone see what I did there, how I did it? They understood how to do it, and they can do it on their own. If you did not, guys, please ask me now, because it's very important, and I want you to understand this. Questions, comments, concerns, problems? Okay, I'm trying. Now let's do our test. Let's test it out. What's a value less than negative 3? Okay, so let's test our first interval. Negative 4, that's going to be negative 11 over negative 1. What's a negative divided by a negative? So does this work? Yes, 11 is greater than 0, so yes, it works. That works. Immediately, you know that interval 2 will not work, but I'll prove it. Interval 2, I'm going to choose 0 because that's the easiest one. Negative 7 over 3. Is that greater than or equal to 0, gentlemen? No. Interval 2 does not work. Interval 3 has to work now. But again, you'll figure this pattern out little by little. Give me a value that's greater than 7, please. 8. So 8 minus 7 is 1. 8 plus 3 is 11. Is 1/11th greater than 0? Yes. So that works. You can use 7, absolutely. And then it'd be 0 over 10, which is 0. And this is greater than or equal to 0. So you're golden. But if it was just greater than 0, you could not use 7, right? Thank you, my brother. Does that make sense, gentlemen? So now, what's my solution? Or what are my solutions? Bam, negative infinity all the way to negative 3 with a bracket or parentheses? Parentheses because it cannot equal negative 3, boys. It can never equal negative 3. That's the undefined. Not necessarily the first one always. Maybe negative 3 was my 0. It's open bracket not because it was the first, but because that was my undefined value. Is the one with the parentheses always. The undefined values with the parentheses. Thank you, my brother. In union with? Bam. Bracket 7, positive infinity. Beautiful. Excellent, guys. So what does this mean? That means that this inequality is solved with any value that is less than negative 3 or greater than 7. You plug in any number in those intervals, it's going to work. It's not too bad, is it? Okay. Let's continue rather. Okay, now we're going to complicate things a little bit. A little bit. We have to set this equal to 0, right? But I've got a frickin' 2 here, dude. Okay, whoever said factor, that doesn't even make sense. Oh, okay, subtract, yes. Thank you. Subtract 2 to both sides. So I've got x plus 3 over x minus 1. Minus 2 now is greater than 0. Okay. I wish that we could start from here. But don't I need one single rational expression on one side? So how do I make this one single rational expression? LCD, yes. Old skills coming back to either help you or haunt you. It's your choice. So what's my common denominator here, boys? Okay, so what am my LCD here is x minus 1. Beautiful. I'm proud of you guys. So do I need to multiply anything to this guy? Nah, this is just x plus 3. And everything's going to be over x minus 1. Remember what we did before. Minus, what do I need to multiply to this guy? So it's going to be minus 2 times x minus 1. This is going to give me x plus 3 minus 2x plus 2. All of it over x minus 1, which equals negative x plus 5 over x minus 1 is greater than 0. Now I'm ready to rock and roll. But before I do, does everyone understand what I did, why I did it, and how I did it? Sir, my brother, thank you. It's not that it's fine to keep it. That's the answer. It's negative x plus 5. Don't complicate your lives. Put the answer the way it is. I don't know what the other way would be. Well, then you're factoring out a negative and you're complicating your life. So if you want to complicate your life, Godspeed, man. But I suggest not to complicate your life. Thank you for your honesty, sir. Any other questions before now we solve this sucker? Yes, sir. Okay, let's solve it. Step 1, what is my 0 or zeros? Yeah, because you subtract 5 and divide by a negative, right? So it's 5. X equals 5. Now, my undefined value. I'm sorry, my brother? Cannot equal 1. Okay. X cannot equal 1. Now, let's think about this for a second. If I have, for my 0, if x equals 5, I have 0 over 4, which is 0, correct? But this is greater than 0, not greater than or equal, right? So x cannot be equal to 5, really. X has to be greater than 5, okay? So 5 cannot really be an answer. So we're going to use open parentheses with it, right? And actually, let's be fair. X can be greater than 5 or maybe even less than 5. It depends. It's just not equal to 5, okay? So now let's do our intervals. I got my 0. I got my 5 with an open circle. Because even though my 0 is 5, okay, and I shouldn't really put this greater than thing because that can confuse people. The 0 is 5, but since this is not greater than or equal to 5, there are going to be no brackets in your answers. Because if x equals 5 purely, then the value of this inequality is 0. And the value of this inequality has to be greater than 0, not equal to 0. So be careful. Pay attention. Be cognizant of what they're asking you. And then my undefined value is 1. So I got a 1 here. And that is also open circle. X cannot be 1 or 5 in this particular case. Why can't it be 5 more? I don't understand. That's the 0. It is the 0. But remember, it's greater than 0, this inequality, not equal to. Do you guys see the difference there, my brothers? Sir?
Why aren't you like plotting it on the number line with parentheses and brackets? And like, why are you doing it with circles?
I could plot it on the number line with parentheses or brackets, but I don't know which parentheses, which way it's going to go yet. So I'm just leaving an open circle. Remember, on a graph, open circle means greater than or less than. It's just the same as parentheses, right? And on a number line, a closed circle equals greater than or equal to or less than or equal to. It's just like a bracket. But since I don't know which way the bracket's going to face, I'll worry about that at the end when I actually put in my solutions. Thank you for caring. Great question, my brother. So now my intervals. Okay, to the left of 1, that's interval 1. In between 1 and 5, that's interval 2. And to the right of 5, that's interval 3. So let's do it. Let's check it out. Let's check interval 1. What's the value to the left of 1? That's nice and easy. 0, yeah. So 5 over negative 1. Is that greater than 0? No, it's not. So no, that does not work. 2. What's the value between 1 and 4? Let's do 2. So I got negative 2 plus 5, which is 3, over 2 minus 1, which is 1. So is that greater than 0? Yeah, 3 over 1 is greater than 0. That works. 3 is automatically not going to work, but I'll prove it. What's the value to the right of 5, greater than 5? 6. Negative 6 plus 5 is negative 1. 6 minus 1 is 5. Is negative 1/5 greater than 0? No, just as promised. Just as promised. That's the pattern always. So, my brother. Correct, sir. If this one was correct, then 3 would have worked. But if 1 does not work, 3 will not work, and the middle will. Thank you, sir. Bless you. Thank you. Great question, son. So now in this particular case, the only one that works, the only interval that works is 2, which is between 1 and 5, right? So what's my solution here? How do I write that in interval notation in this case? Parentheses 1 comma 5. Guys, it seems like your interval notation skills are a little weak. I suggest you go back to my prior videos on that, or come see me, or practice. Because without interval notation, this is going to be miserably difficult. Okay. Does that make sense, boys? Questions? Gentlemen? Okay. Let's move on then. Uh-oh. Oh, what the? Uh-oh. No big deal. Isn't that already, guys, one rational expression? Yeah. Do not multiply these two here. If you do, you're going to have to refactor them anyways to find your zeros. So this is actually quite an easy problem. The way I'm going to do it in real testing quizzes, the way the SAT does it, they don't break it up into its factors already. They'll give you the full polynomial and expect you to factor it. Again, factoring skills are going to be important here too. So in this case, it's pretty simple. We're jogging before we run here. So first things first, what is my zero or zeros in this case? Okay, so x, and it's less than or equal to, so it can equal it. So 2/5 is 1 0 and -4. Those are my zeros. What are my undefined, not unified, but undefined? X cannot equal 5. Very good. Now, let's do it, my brothers. Now here, the 1, 2, 3 pattern is going to change because now we're going to have 4 intervals. I've got my -4, which it can totally be. My 2/5, which it can totally be. Here's my 0. I always put my 0 in there because that way I have a reference point on the graph. And I have my 5, which it cannot be. Now, what are my intervals here? Well, here I can be less than -4. I could be greater than -4 but less than 2/5. Or in other words, in between -4 and 2/5. I can be greater than 2/5 but less than 5. That's interval 3. And then I can be greater than 5, which is interval 4. Now here, guys, there's not a pattern. Okay? But I will tell you this. 99% of the time, I would venture to say even 100, it's never going to be both 1 and 2 or 3 and 4. It'll either be 1 and 4 or 1 and 3 or 2 and 4, okay? Or 2 and 3. But they're usually not going to be right after each other. So they're usually not going to be 1 and 2. It just won't make sense. So let's test it. Let's test number 1. What's a value less than -4? -5, right? So I got a -5 times 5, that's -20. So that product is going to give you a negative. I don't care what the product is, but it's going to give you a negative, won't it? Do you understand? No? -25 minus 2. That's not going to give you a negative value? Yeah, that will give you a negative value. Times -5 plus 4. Will that give you a negative or a positive value? Do I really care about the actual value of it at this point? I don't care about the value. I care about the sign. Because it can be a super small positive, and as long as it's a super small positive, it's not less than 0, it doesn't work. So I don't care about the value. I care about the sign. Down here, -5. A negative and a negative, is that going to be a negative or a positive? Negative. So what's a negative times a negative? Divided by a negative? So is this going to work? Is that going to be less than or equal to 0? A negative is less than 0. Yes, so it works. Interval 2. When x is 0. 0 minus 2, that's a negative. 0 plus 4 is a positive. And 0 minus 5 is a negative. What's a negative times a positive divided by a negative? A positive. And is a positive less than or equal to 0? No, so interval 2 does not work. Interval 3. Give me a nice pretty number in between 2/5 and 5. 2. 2 works good. So 10 minus 2, that's a positive. 2 plus 4 is a positive. And 2 minus 5, that's going to be a negative. So is that less than or equal to 0? Yes. So 3 works. 4 will not. But let's prove it. Give me a nice pretty value greater than 5. 6. So 30 minus 2, that's a positive. I don't care what the value is. I just want the sign. 6 plus 4, that's a positive. I don't care what the value is. I just want a sign. And 6 minus 5 is positive. Is that less than or equal to 0?
That's greater.
Yeah, that's greater. So this does not work either. So what is my final solution here? Look at the graph. Open parentheses. Negative infinity to negative 4 with a bracket. In union with bracket 2/5 to 5 parentheses. Questions, comments, concerns, issues, sir and sir.
The last example, you had put that one equals, but now we must find out.
Come again? Yes, sir. That's why I put an open circle, because it can't equal 1. You're absolutely right. I did exactly the way I taught you. Thank you so much for your honesty, sir. Questions on this solution, gentlemen? Please ask now before I go to example 4. Yes, sir.
That method that you didn't actually look for the solution itself, just look for the positive, that work for all of them?
Yes, you don't ever have to find the values. You just want the signs. You don't want to need the values. You want the values? That's fine. It's just more work for you. Just find the signs, my brother. Sir. Sir. Because okay. You want this rational inequality to be less than 0, less than or equal to. A negative times a negative is a positive. Divided by a negative is a negative. Isn't any negative number in the universe less than 0? Sir, yes or no? Okay, so then what are you asking? I don't need the numbers. I just need to know, is this going to be a positive or is this going to be a negative? If it's a positive, then it's greater than 0. If it's a negative, then it's less than 0. I'm saving you time here. You want to find the values? Do it, guys. There's nothing wrong with that, except the fact that you're going to run out of time. Find the sign of the inequality that you created. Sir, does that answer your question, my brother? Thank you so much. Any other questions on example 3, gentlemen? Okay, let's do it. Uh-oh. No, uh-oh. More like, yay! What's the LCD? X times x plus 3. Great. So what do I need to multiply here to this first fraction? On x. And to the second, an x plus 3. So I've got 2x plus 2x plus 6 over x times x plus 3 is less than or equal to 0, which is 4x plus 6 over x times x plus 3 is less than or equal to 0. Done. Now I'm ready. What are my zeros? Or 0? X is less than or equal to, or x is equal to negative 6 over 4, but let's go ahead and reduce that. 3 over 2. Very good. And what are my undefined values? 0. Excellent, son, and negative 3. Great job. X cannot equal 0 or negative 3. Beautiful job, son. Now, let's make our intervals. Always start with your 0, guys, so you can have a frame of reference. So, and actually, in this case, 0 not only is for reference, but it's part of the undefineds. So I have an open circle on 0. It cannot equal 0. I have an open circle on negative 3. It cannot equal negative 3. And I should have split this up a little bit further. Hold on. Let's do this over here, the negative 3 open circle. And then I have a closed circle on negative 3/2. Questions, comments, concerns, problems, issues? Bless you. Okay, so I can go to the left of negative 3, it's quadrant 1, Between negative 3 and negative 3 halves, that's interval 2. Between negative 3 halves and 0, that's interval 3. And then to the right of 0, which is interval 4. Now let's test. Give me a value less than negative 3. Negative 4. Okay, remember, we're plugging it into this. If you plug it into the original guy, if you plug it into here, it gets pretty difficult, right? Because now you got to start adding and stuff. Use the single rational expression that you created with your hard work. So, you said negative 4. So I got negative 16 plus 6. Okay, that's going to be a negative over negative 4, right? So I got a negative 4 times a negative 1. That's a positive. Is that greater than or less? Hello, what am I doing? Does that work?
Yes.
Yeah, a negative divided by a positive is a negative, so interval 1 works. Let's try interval 2, which is not going to work. What's a nice pretty number between negative 3, negative 2? So negative 2 times 4 is negative 8 plus 6. That's a negative up top. And you have a negative 2 times negative 2 plus 1, plus 3. Negative 2 plus 3 is 1. 1 times negative 2 is a negative. So I have a negative here. Is that less than or equal to 0? No. Interval 2 does not work. Interval 3. What's a pretty number between negative 3 and 0? Negative 1. So negative 4 times negative 1 is negative 4 plus 6. That's a positive. Over negative 1 times negative 1 plus 3. That's 2 times negative 1. That's a negative. Is that less than or equal to 0? Yes, a negative is less than or equal to 0. Interval 3 works. And 4, which will not work either, but I'll prove it. Give me a nice pretty number greater than 0. 1. So 4 times 1 is 4 plus 6. That's a positive. 1 times 1 plus 3. That's positive. Is that less than or equal to 0? No, does not work. What's my solution, gentlemen? Negative infinity to negative 3. Union with bracket negative 3 halves to 0 parentheses. Gotta admit, this is pretty cool. And I think it's easier than the solving equations. It's a little bit longer, but it's easier. The steps are easier. I mean, it is what it is. Sir. Questions, comments, concerns? Okay. Yes, sir. The first example?
No. On this solution.
Oh, for interval 1. Okay. We chose negative 5. Negative 5 times 4 is negative 20. Negative 20 plus 6, I don't care what it is, but I know it's going to be a negative because there's more negatives than positives. And then you have negative 5 here for the x times negative 5 plus 3. Negative 5 plus 3 is negative 2. Negative 2 times negative 5 is a negative times a negative is a positive. Negative over a positive is a negative. It is less than or equal to 0. Listen, wait, please. Listen, guys. You still have 2 more examples that I want you to do. I'm going to check these examples tomorrow for a grade. Okay? If you're not here tomorrow, then I will check it on Monday for a grade. Also, if you need extra practice, simply scan this with your iPad. It will take you to a website with more questions like this with answers. Okay? Homework is valid. It is valid, guys. Please remember this. It's on a recording. Finish the last examples. I will check it on Monday for a grade. Homework is valid. And if you need extra practice, scan this. May God bless you. Have a wonderful day. I hope you learned a lot. Thank you. He's not.